In the olden days of Android, there wasn't an easy way to schedule a periodic job with complex run rules, like run within 15 minutes, but only while on Wi-Fi, charging, and if the job fails, keep retrying, but wait more time between retrying the job to not overwhelm the network. That's a lot of constraints to keep straight. Well, first, you'd need to set up a mechanism to trigger the job after 15 minutes. Then, when the job was triggered, you'd need to check all the Wi-Fi and charging constraints manually. If the user wasn't on Wi-Fi or charging, you'd need to manually calculate when to reschedule the task. Your app also would have to be instantiated all the time just to check to see if it has to run your job. Needless to say, things were complicated. Thankfully, there's an easier and more battery-friendly way. In Android L, Job Scheduler was introduced. Job Scheduler allows you to simply grab a reference to a Job Scheduler object from the context, create a new job with all the constraints you wanted, and then schedule the job whenever you want by calling js.schedule. In this course, we'll be using a class called Firebase Job Dispatcher, which is a more compatible version of Job Scheduler. Since Job Scheduler was introduced in Android L, it only provides compatibility back to API level 21, whereas Firebase Job Dispatcher provides compatibility back to API level 9 Gingerbread. Here's what using Firebase Job Dispatcher looks like. First, you make a Google Play driver and use that to create a new Firebase Job Dispatcher object. Then you build the job, specifying all the constraints. In this case, the job triggers the MyJobService class. It has a unique identifier called a tag, which is set to complex job. The job doesn't recur, and it doesn't persist if the device is rebooted. It starts between 0 and 15 minutes and will replace a current job with the same tag if one exists. It uses an exponential backoff strategy as a failure strategy. Jobs, especially network jobs, might fail if a server is down. An exponential backoff strategy will keep retrying the job, but will wait longer and longer between successive attempts. Finally, this job will only run on an unmetered network like Wi-Fi and while charging. Taking a closer look at the timing, we see that we can set when the job executes by using the setTrigger method and passing in an execution window. The times supplied here are in seconds. The first time is how long from when the job is scheduled, at minimum, before the job service executes, and the second time is the maximum time before it executes. The second time must be greater than the first. This all assumes that all the other constraints are met. Other constraints could be things like, the device is currently plugged in. So if you put 60 and 120 as these parameters, the job service would execute somewhere between 60 seconds and 120 seconds after it's scheduled. Why the window? Battery life is saved if the phone can do a bunch of processing, especially network calls all in a batch. This allows the phone to stay more continuously in a low power state if the user is not actively using the phone, which means more battery life for your user. Supplying a window lets the system pick the best time to schedule your job in that window. I've provided the sample code below. Now that you know a little bit more about Firebase Job Dispatcher, it's time to make your first job.